In this quick little review, we're going to review momentum briefly and then look at some of the problems from your momentum review in your assignment packet. The first thing that we need to remember is the definition of momentum as the quantity of motion, simply mass times velocity. Its unit would be kilogram meter per second. The second thing that we need to remember is that the definition of impulse is force times the change in time. The unit for that is also kilogram meter per second. The third thing to remember is that the change in momentum, final minus initial, is equal to the impulse or force times change in time. So remember, you can find a change in something by subtracting the final minus the initial value. So if I ask you to find the impulse in a problem, you might be using force times the change in time, or you might be finding it by finding the change in the momentum by subtracting like that. You need to recognize what the question gives you and do the correct thing accordingly. If you don't have any forces acting on a system of objects, such as two cars on a track, then the total momentum is conserved. That means that the total remains the same. The momentum that you begin with before a collision or explosion has to equal the momentum after the collision or the explosion. So again, we use that to analyze collisions and explosions. So keys to understanding what concept to use. Am I going to use impulse, momentum, or am I going to use conservation momentum? Look at what the problem's giving you. If you see a force, if you see an impulse, if you see a change in momentum, then you're going to use impulse momentum theory, like concept number one. If it's a collision or if it's an explosion, the momentum's going to be conserved and you're going to use concept number two. So let's look at some of the problems from your review. In question number 6 on page 10, you're told that a 0.4 kilogram marble is initially rolling with a velocity of 12 meters per second to the right. So that's the picture that I drew. You're then told that a force of 4 newtons is exerted on the marble to the left for 3 seconds. You're asked to figure out the new velocity of the marble. What we need to realize is since there's a force involved, that means that there's a change in momentum. I can find that change in momentum by doing impulse equals F delta T. So my force is 4 newtons. Since that force acts to the left, and my object is initially rolling to the right, then I'm going to make that 4 negative. And you're told that the time period is 3 seconds. So the impulse on this object is like negative 12 kilogram meter per second. That impulse tells me how the momentum is changing. So in order to figure out what the final momentum is, I'm going to have to figure out the initial momentum. So initial momentum is simply going to be the mass, which is 0.4 kilograms, times the 12 meters per second, which is the original velocity. So my initial momentum is going to be 4.8 kilogram meter per second. If I add the initial plus the change, that gives me the final. So I started with 4.8 kilogram meter per second momentum. I lost 12, lost because the change is negative. So my final would be 4.8 minus 12, which is negative 7.2. Now that I've got the final momentum, all I have to do is divide by the mass to get my final velocity. Notice that your velocity is going to end up being negative since your momentum is negative. So divide negative 7.2 by the negative 0.4 kilograms, you get a final velocity of negative 18 meters per second. What that means is that when we put a force on this marble, it went from going to the right so that it's now moving to the left. If you look up above at question number 5, it's essentially the same question, only it's giving you the impulse. You don't have to calculate the impulse using F delta t, the stuff that we did right here in blue. In question number 5, that's already done for you. So it's the exact same question, just with that step already done. Let's look next at question number 10. In question number 10, you're told that a kickball is rolling to the right with a velocity of 12 meters per second, and then Billy kicks it back, so it's moving in the opposite direction, with a velocity of negative 36 meters per second. So your picture is going to look something like this. The question tells you that the foot is in contact with the ball for 0.4 seconds, so that's like a delta t. And the question is, what force did he exert on the ball when he kicked it? So force is your question mark. Again, momentum's not being conserved, so there's some impulse being exerted on the ball. That's what we need to figure out first. In question number 6, we figured it out by using the F delta t equation. However, we don't know what the force is. Like, that's missing. So we can't do that. We need to figure out what the momentum is by doing the final minus the initial. So when you do mass times velocity, the initial momentum is 6 kilogram meter per second. The final momentum is negative 18 kilogram meter per second. Again, negative because it's going backwards. So to find your impulse, you just subtract final minus initial. So your delta P, your impulse, is negative 18 minus 6, which is negative 24 kilogram meter per second. Now that I know what the impulse is, I'm going to use my impulse momentum equation to figure out what the force is. My impulse was negative 24. We're told that the time is 0.4 seconds. All I have to do is solve that thing for F and get delta P over delta T. So your delta P, again, was negative 24. Our time was 0.4 seconds. And that's going to tell us our force. So when you do your arithmetic, that would be negative 60 newtons for your force. And that's our final answer. In question number 7, you're told that you have 2 cars traveling in opposite direction, one with a mass of 1,500 kilograms and a velocity of 15 meters per second, the second with a mass of 800 kilograms and a velocity of negative 5 meters per second. So they're going in opposite directions. So your before picture looks like this. The after picture is the 2 cars locking up. After the collision, the 2 cars are locked together. So that means that they're stuck together. That's an inelastic collision. So you go from 2 objects to 1 object. The mass of that one object is simply the combined masses of your 2 original objects. You simply add up the 1,500 and the 800. So we know what the mass of that one object is going to be after the 2 collide and stick together. If we knew what the momentum of that one object was, then we could figure out its velocity. So what we need to do is we need to use conservation momentum to figure out what the total momentum of this system is. Remember, that's the key thing that you need to always find first. What is the total momentum? So that means we need to figure out the momentum of our objects before the collision and simply add them up. So the momentum of the first car, due mass times velocity, is 18,500. The momentum of the second car, mass times velocity, is negative 4,000. When you add those 2 together, remember, make the blue one negative, you get 14,500 kilogram meter per second. Remember that since the momentum is conserved, that means that the before and the after total momentum are both the same. So momentum on the before side is 14,500, and the momentum on the after side is 14,500. So the total momentum of this one object that we're dealing with at the end, two cars stuck together, is 14,500. So to figure out the new velocity, I just have to do that new momentum divided by the mass. So when you plug in those two numbers, you should get 6.3 meters per second. What that tells you is that these two things are moving to the right. Draw an arrow going to the right to indicate that velocity. Moving on and looking at question number 8, very similar question. You've got a conservation momentum problem because it is a collision. In number 8, you're told that a red car of mass 1 kilogram is pushed forward with a velocity of 1 meter per second. Blue car with double the mass, so mass of 2 kilograms, is pushed towards the red car with a velocity of negative 0.5 meters per second. So in question number 8, we're told that we have a red car being pushed towards a blue car, and we know both their masses and we know both their velocities. So our picture will look something like this. Afterwards, they bounce apart from each other. We're told the velocity of the red car is negative 1 meter per second. Our job is to figure out what is the velocity of the blue car. What we're going to do is the same as what we did on the last question. Use conservation momentum. That means the first thing we need to figure out is the total momentum of our system. So we're going to use the before picture, find the momentum of the red car, find the momentum of the blue car, and then add them up. So when you do that, you get the momentum of the red car to be 1 kilogram meter per second, and the momentum of the blue car to be negative 1 kilogram meter per second. So when you add 1 and negative 1, you get the total momentum to be 0. That's a perfectly legitimate American number. Don't be scared of 0. That just means that they have the same momentum but in opposite directions. Our total momentum after the collision would also be 0. Again, momentum is being conserved. So this number here and this number here have to be the same. So our strategy now is to recognize that they have to add up to 0 after the collision, and so we need to figure out the momentum of the red car after the collision. After the collision, the red car has a momentum of negative 1 kilogram meters per second. Since they have to add up to 0, that means that the momentum of the blue car is negative 1 kilogram meter per second. Now all I got to do is finish the problem off by finding the velocity of the blue car. So just do your momentum over your mass. So it's negative 1. And the mass was 2 kilograms. And we find that the momentum of the blue, or the velocity of the blue car, is negative 0.5 meters per second. Question number 9 is kind of the same, where the total momentum is 0, only it's more of a inverse of a question like that. Two things are pushing each other apart. Hopefully this tutorial was helpful to you. If you still have questions, please come see me in the morning. We'll try to work through them together.